Hello. So I know I couldn't be there today to work with you guys on the next part of your target. So I decided to make some notes for you. I kind of planned ahead a little bit, so you might have to stop and take notes as we go along. Now, one of the skills that you're going to have to be able to do for this target is be able to write an equation from a table. Now, when we write an equation from the table, remember, we are still using the same equation that we've been using all along. Y equals mx plus b. And when we use this equation, remember that m will be a number, mb will be a number. So our goal in writing an equation from a table is to find m. We need to find a number for m, which is our rate of change. And we need to find b, which is our y-intercept. Now, the y-intercept, remember, we can find the number when x is 0. So we're going to practice finding m and finding b, and then writing the equation that fits the table. Now, sometimes it's easier, sometimes it's harder. It's easier when x is 0 is already in the table. So we're going to notice that today. We're going to take a look at this table, and we're going to notice that x is already 0 here. It makes the problem a little bit easier. So we will start here. So I notice that I have a table here, 0, 2, 3, 8, 6, 14, and 10, 22. Now, in order to write that equation, the first thing that we want to do is find the rate of change. Okay, so that's going to be our first step. We're going to find our rate of change. And when we find that rate of change, remember, m is our change. And I don't know if I've talked to you guys about this, but this triangle sign is called delta, and it means change. So we're looking for the change in the y over the change in the x. And now we've done this. It may look a little bit different today because I've added that delta, that change, but that's an important symbol that you will see in science as well. So I thought it was important that we talked about that today. Now remember, in order to find the rate of change, we actually come over to our table here and we look at how our numbers are changing. Now, in our y, we are going from 2 to 8. So I want you to think about, how did that change? How did we get from 2 to 8? We added 6. Now I'm going to check and see if this is a constant rate. So if 8 becomes 14, what do we have to do to 8 to become 14? We also add 6. Now notice from 6 to 10, from 14 to 22, that one's a little bit different. 14 to 22, that's 6, 7, 8. We increased by 8 there. But I'm going to see if that makes a difference. So now that we have our change in y, let's see if we have what our change in x is. So our change in x, notice I start at 3 and I go to 0. Oh, sorry, other way around. I start at 0 and go to 3. How did that change? From 0 to 3. I added 3. Now what about from 3 to 6? How does that change? We're going to add 3. Now remember, it was a little bit different over here. Let's see what happens here. How do I change from 6 to 10? It's a different number this time, right? It's 4. So now to find my rate of change, to find my m, I'm going to put some of this together. Remember, m is the change in y over the change in x. I'm going to look at these two right here, from 0 to 3 and 2 to 8. Notice that the change in y is 6. The change in x is 3. Now I have another change happening here. From 14 to 22 is 8. From 6 to 10 is 4. Now, we have had the discussion before that these can be simplified, right? These can be simplified. 6 divided by 3 is 2. Notice that 8 divided by 4 is also 2. So our m is 2. Our rate of change is 2. Even though it was slightly different in the table from this number, from this x to this x and this y to this y, it still is a constant rate of change. It still is changing by 2 every time. Notice we are taking our x, multiplying it by 2 to get to the y. 3 times 2 is 6, 4 times 2 is 8. Now that we have our m, we need to find our ordered pair of 0, comma b. Okay. Remember, if we have an ordered pair with 0, comma b, b is our second value, our y value is our y-intercept. So I'm going to look for the table, the ordered pair that has 0, comma something. Notice that right there, 0, comma 2. Since 0, comma 2, my y-intercept is 0, comma 2. And since 0, comma 2 gives us our b, I now have the numbers that I need to write my equation. Remember, y equals, we want to have m is a number, and then our b needs to be a number. So let's go ahead and pull it from what we've already found. Y equals, we decided that m is 2, and our y-intercept was also 2. So our equation is y equals 2x plus 2. So if you need to at this moment, pause the video, go back over the problem, maybe listen to it a second time. When you're ready, let's go to number 2. I'm going to draw a little line here just so we know we're starting a new problem. And I'm also going to box this because these are our steps. Remember, these are our steps. Okay, number 2. First thing we're going to do is find the rate of change. Remember, change in y over change in x. So I'm going to look and see how these are changing. What's happening from 0 to 2.5? And I want you to stop and think what's happening from 2.5 to 5. Take a moment and do this one on your own, because this is kind of a review of what we did last week. You should be noticing that we are adding 2.5 every time. Now what's happening on our x side, our x column? From 0 to 1, I am doing what? Take a moment to figure out what our rate of change is in our x. You should be noticing that we are going up by 1 every time. Again, make sure you take time to take your notes. Taking notes is really important because it helps it stick in our brain. Okay, so now that we know what's happening in the table, let's switch it over to our equation. Remember that m is the change in y over the change in x. My change in y for one of my coordinates, one set of my coordinates, or sorry, ordered pairs, is 2.5. My change in x is 1. So we simplify this as mathematicians to be 2.5. Now sometimes you might, 2.5. Let's just leave that there. So m is 2.5. So now we're going to move to our second step. Our second step is to find the ordered pair of 0, comma b. I'm going to move to my table over here. I notice that I have x is 0. That is my ordered pair that I want. Now that looks tricky. That's 0, 0. Very important that we notice this. Okay, so y-intercept is 0, 0. In this case, our b is 0. Now that's totally okay. In fact, it's going to make our equation. We can still plug it in just like we've always done. Y equals mx plus b. Remember, m is our rate of change. That will be a number. And b is our y-intercept. And that also will be a number. So y equals, remember, m up here, 2.5. I leave my x value. Now, my b is a plus b, so it would be plus 0. But you know what I say about mathematicians. If we don't have to write it, we don't. So this equation is actually going to be y equals 2.5x. And that's that. Now, depending on your time, this might be enough for today, and you can pause and watch the rest of the video tomorrow. Or I'm going to go ahead and move on to when x is 0 is not in the table. Okay, so sometimes x equals 0 is not in the table. So notice my table, I've got 1, 1, 2, 5, 3, 9, 4, 13, and so on. We do not have an x equals 0. So there are two methods that you can do. The first method, you just kind of have to think it through. I'm going to create my new table, and I'm going to leave a spot for 0. But I don't know what this number is. So that, remember, my goal is always to find the b. So I'm going to go ahead and fill in, oops, that wasn't, yeah, there we go. I'm going to fill in the points I already know. Right? So I've got 1, 1, 2, 5, 3, 9. I don't need all of them. We're going to do the same thing we had been doing on the last page. We're going to find our rate of change. How does 1 become 5? How does 5 become 9? Take a moment to do that. How does 1 become 2? And how does 2 become 3? Go ahead and take a moment to do that. I notice that 1 becomes 5 by adding 4. 5 becomes 9 by adding 4. On our x side, I have to add 1. 1 plus 1 is 2. And then 2 plus 1 is 3. So my rate of change is 4 over 1, right? For every 4y, x goes up 1. So now what I'm going to do is I'm going to use this and go backwards. So that's why I said this one takes a little bit of thinking, because you have to like wrap your brain around that. If I'm moving down the table, notice I'm adding 4. Well, what do we know about inverse operations? If I'm adding 4 as I go down the table, what am I going to do as I go up the table? If this is the opposite, I'm going to use the opposite. I'm going to subtract 4. Because notice over here, to get from 1 to 0, I have to subtract 1. So notice I've used a different color because we're moving in a different direction on the table. So now, what happens if I have 1 and I subtract 4? Well, that makes it a little bit trickier. Let's come up here. Here's my number line. I have a 1. But my minus 4 tells me I have to go left 4. So I'm going to go back 4. 1, 2, 3, 4. Now that's a negative 1, negative 2, negative 3. Okay, so that means my y is negative 3. And I know that's kind of small. I can't zoom in anymore. So hopefully you guys can see that. So now I've got everything I need. Okay, first of all, y equals Remember, we want y equals mx plus b. I'm just going to write it really small up here so I remember. My m, my rate of change, my change in y, right here. Remember, let's look at the pink part. Right, remember? We are adding 4 over 1. But as a mathematician, I'm just going to write 4. I keep my x. And then remember, this is our y-intercept. Remember, we have 0, comma, -3. So this -3 is my y-intercept. -3. Now, this might help you to watch this a second time. If you need to pause and rewind, you can do that. Now, there is a second method, and I don't feel like I would be a good math teacher if I didn't show you another method. This one is using the table and just using your thinking and being flexible and going backwards. The second method is to actually start with the equation, mx plus b. Notice what we don't know is our b. We know everything else. My m, we already know, is 4. And we actually do know, we could know what y and x are. Notice we have lots of points in our table. This is an xy that works. So we can also pick 2, 5, 3, 9. This is an x and a y, and these x and y's are meant to be in this equation because they are solutions to this equation. So I can actually use that information in here. So in this case, y is 1. So I can write that, y is 1. And x is 1. Now what I don't know is my b. Notice it's the only variable, so that means we can solve for the variable. 1 equals 4 times 1 is 4 plus b. Now I have to get b by itself. Remember, that's always our goal. We want to get variables by themselves, so b needs to be by itself. So in order to get b by itself, I need to move this term, and this term is a positive 4, so I'm going to subtract 4. Subtract 4. I recognize that subtract 4. Where did we see that? Remember over here. Remember, mathematicians are always looking for patterns. This is a 0. 1 minus 4. Oops, we did that up here. Remember, 1 minus 4 is -3. And again, we know what b is. So 2 methods. Do you like to think backwards and just make a new table and add in 0 as your x? Or do you want to use the equation method? And I'm going to let you know, as a mathematician, sometimes I use this one. Sometimes I use this one. That's the cool thing. When you know 2 methods, you use the best one at the moment. If you need to pause and take some videos, or sorry, take some notes, or even watch the video a second time. Sometimes it helps to see it a second time. Okay, so let's go ahead and do problem 4, last one. Again, notice I do not have x is 0 in my table. Method 1, I'm just going to recreate my table with a 0 in it, and I'm going to find my y. 2, 5, 4, 8, and that's enough. Remember to go from 5 to 8. What happens? I'm adding 3. How am I going from 2 to 4? That's my dog. I'm adding 2. Now, using the table method, when we move up the table, we're going to do our inverse operation. We're going to do our opposite. Since I was adding 3 to go down the table, I'm going to subtract 3 to go up the table. On my x side, I was adding 2 to move down the table. So to go up the table, I'm going to subtract 2. If I do that, 2 minus 2 is 0. Kind of knew that was going to happen. I planned that. So what is 5 take away 3? Notice our b is 2. So now I have enough information to write my equation. Remember, m is my change in y over my change in x. So 3 over 2. And as high school mathematicians, we get to leave that as a fraction. And my plus b is a positive 2. So I'm going to write positive 2. And there is my equation. Now remember, what this is stating, and I need to remember to keep coming back and reminding you. Remember, this is like starting with 2, like I'm starting with $2 in my pocket. And I'm adding, this would be $1.50, 3 halves every time I work an hour. Okay, that's really bad pay, but just think about that. I'm starting with 2 and I'm adding 3 halves every single time. Always put your equation into some idea, because then it helps you to understand the numbers better. Now, just to show you the other method, just in case you like that method, remember we start with our y equals mx plus b, and yes, we normally leave b and, x and y as variables, and m and b as numbers, but sometimes when we don't know the number, we can use x and y to find it. I'm going to pick one number, one ordered pair from the table. Let me get a different color pen so I don't confuse you guys. I'm going to pick 2, 5. 2, 5. And I'm going to bring that over and put that in my table. Now remember, 2 is my x, so I'm going to put in the 2. Y is 5, so I'm going to put in 5. And remember, we've already found out that slope is 3 halves. Oh, this is going to be a little bit messy, but that's okay. Fractions are our friends. We're going to work on that. I have 3 over 2. Don't worry, I'll get you through the fractions. 3, 2. And then we don't know our b. Now, in order to solve and find b and isolate the b, we do have to deal with this fraction. Okay, let's go ahead and do that down here. Just in case fractions seem a little intimidating, remember, you know what, let me not leave so much space just to keep you guys on the camera. Okay, so 3 over 2 times, now that's a 2. It is easier to multiply fractions when they're both in fraction form. The cool thing about 2's is they are just over 1. Same with, any number over 1 is itself. Remember, 2 divided by 1 is still 2. Now, when we multiply, remember we do multiply across. 3 times 2 is 6. 2 times 1 is 2. That is the basic multiplication. If you are not at a point yet where you are cross simplifying, I'm going to do this. It might confuse you, but some of you are going to recognize it. Either way, you're going to, you know what, let me put this one back up here. I want to show you that other method that some of you may have learned when you were in K-8s. Notice that our 2's are across from each other. Because they are across from each other, we can cancel them out and make 1's out of them because they are the same value. So now I have 3 times 1 is 3, 1 times 1 is 1. If this part confuses you, don't worry. When we come back up here, this does need to be simplified, and I taught you last week how to simplify that. 6 is the same thing as 3 times 2, and 2 is the same thing as 1 times 2. This becomes a 1, so my answer is 3. So there's a lot of math there, but remember what that means is we basically found out that our b is 3. You might have to watch this a second time. I know I would have to if I was learning this. So now back to writing our equation. Y equals Remember what m is, 3/2. X, and then we found out b is 3. Okay, now that's the end of my video. I do have some practice for you. If we need to, we can go over this again when I'm back tomorrow. Thank you for watching. Have a fabulous day, mathematicians.